Good. All right, we did the warm-up here. So here we go. Talking about diagonals. We saw what a diagonal was in that warm-up. A diagonal of a polygon is a segment that connects any two non-consecutive vertices within a polygon. The vertices of polygon PQRST that are not consecutive with vertex P. So starting at vertex P, T doesn't count because it's consecutive. It's right next to it, but S is good and R is good. Q is also right next to it. So there are two diagonals from point P. And there are three triangles total, which means there are two more sides than triangles, meaning there are 5 sides, which makes this a pentagon. So notice that the diagonals, vertex P separates the polygon into 3 triangles. The sum of the measures of a polygon is the sum of the angle measures of the triangles formed by drawing all of the possible diagonals from one vertex. So there's 3 triangles. Each triangle has 180 degrees. So it would be 180 times 3 in terms of the total number of degrees in the polygon. Or this is what we wrote, or this is what I wrote on the board. I used S minus 2, N also works. So this is the formula for the number of degrees. So we're just talking about degrees. We're not talking about side lengths or anything, but the number of degrees within any polygon can be found by using the polygon interior angles sum theorem. It's a really long title. The sum of the interior angles measures of an n-sided convex polygon, meaning all the sides are facing like outward. Like if it goes out, it doesn't cut back in, is basically what we're saying. It doesn't cut in, it's always outward facing. That's what convex means. And we won't see concave. Concave is the opposite. We won't see concave polygons. We're only going to look at convex. The formula is right here. N minus 2 times 180. The number of sides minus 2 tells us the number of triangles. And if there are 3 triangles, you multiply that by 180, and you end up with 540 degrees. So this formula is going to be very important. We will use that many times. So I have a feeling that at least today's notes are going to be maybe a little bit simpler than last time. I can promise you there are not as many different things that are different that seem so similar as last unit, right? In-center, circumcenter, centroid, orthocenter, those are all centers of triangles. They all seem really similar to each other, so maybe it's hard to differentiate between what they were. It will not be like this in this chapter. We're going to be talking about quadrilaterals, mostly quadrilaterals. We're starting with polygons, but most of this unit is about 4-sided shapes. So let's get going. Find the interior angles sum of a polygon. So first of all, how many sides are in this shape? Tells you right here. 5. Okay. Now, the number of degrees is going to be the number of sides, 5, minus 2. It's always going to be minus 2 because there are always 2 fewer triangles than there are sides. So 5 minus 2 would be 3. And then 3 times 180. Does anybody remember from the warm-up how many degrees were in a pentagon? What's that? What's that? 540. Yeah, 540 degrees. Great. So this says to find the measure of each interior angle. So we're actually going to be figuring out the measure of angle J, which we already know is 142, times the measure of, or not times. We're going to figure out the measure of angle H. We're going to figure out the measure of angle K. We're going to figure out the measures of M and L as well. So the thing that we're going to need to do here is, now that we know how many degrees there are total, we have to add all 5 of those together and set them equal to 540. It's just like when we were dealing with triangles. But instead of adding 3 angles together and setting them equal to 180, we're adding now 5 angles together and setting them equal to the total amount of degrees in a pentagon, which is 540. So it's the same idea. So there's not a whole lot of difference here. So now, step 2, find the value of x. Use the sum of the interior angles of the measures to determine the value of x. So you'll notice here, all of the measures of the angles added together equal 540. 2x and 2x, those were the measures of angles H and K. So angle H plus angle K plus angle L plus angle M plus angle J. I think that one is. Yeah. Equals 540. So let's do the math off to the side because it doesn't actually give us room there, but we get room on the side. So what do we have to do here on the left? We could start with that if we wanted to. I might not, but you could. There's nothing wrong with that. Generally, what I do is if I've got a bunch of stuff being added and subtracted on the left side of an equation, I usually combine my like terms first. But if you want to start by subtracting 142, you can, and then combine like terms. Doesn't really matter. But just to make this a little bit easier, I'm going to highlight stuff. 2x and 2x go together. First of all, because everything is being added, the parentheses don't actually need to be there. If there was subtraction, they would be because we'd have to distribute the negative. But with a plus here, the parentheses don't really matter. So plus 3x plus 3x. That's everything with x. So those will all go together. And then 14, 14, and 142. Those will all go together. So combine your like terms. And then I'm going to write that new equation over to the left, and then we'll plug in for x, or once we get x, we'll go ahead and figure that out in a minute. So 2 plus 2 is 4. 3 plus 3 is 6. 4 plus 6 is 10. So that's 10x. So 10x. 14 and 14 is 28. 28 plus 142 is what? $28 plus 142, 170. Good. So plus 170 equals 540. What is 540 minus 170? Because now we can go and subtract 170 from both sides. 370, good. So 10x equals 370. What's our last step here to solve for x? Yeah, divide by 10, the answer is 37. Good, so x is equal to 37. All right, let's write that back in over here. 37. Great. Oh, we're working at a new 460. Are you all done? No. Not quite? Okay. Page 406. 406. It's right near the beginning of the book. 406. Okay. All right. So now that we have our value of x, which is 37, we need to figure out the measure of each angle. Now, if you flip back to the previous page, how many degrees is angle J? 142. We already knew that one. It just told us it was 142 degrees. The measure of angle K is equal to 2 times x, which is 2 times 37, which is equal to what? 74. Okay. So K is 74 degrees. L is equal to 3 times x, or 3 times 37 plus 14. How many degrees is that? 125. All right. So let's keep going. The measure of angle M, it tells us right here, 125, which makes sense because M and L were the same thing. And then the last one, H is the same as K, which is 2 times 37, which is another 74-degree angle. So what is a good way for us to make sure that we have this correct? Any thoughts? There you go. If you add all 5 angles together, 142, 74, 125, 125, 74. If you add those 5 together, they need to add up to 540 because we're talking about a pentagon. Every pentagon has 540 degrees. So there's a really easy way to check to make sure you've done it correctly. And that's just to add up all the angle measurements and make sure they add up to the number of degrees inside that particular polygon. I'm getting a thumbs up from Brianna because it works, 540. Cool. So any questions here before we take a look at the next one? It should be a pretty, I mean, there's a few pages to get through here, but it's a pretty quick in terms of the learning.
142.
Yeah. Yeah, so 142, 74, 125, 125, 74. Which one? Both of them, yeah. Because J, K, L, M, and H were the 5 different angles inside the polygon. So all these angles here, 142, 74, 125, 125, 74, those are the 5 angles inside. Yeah. So we just got to add them all 5 together and make sure they add up to a pentagon's angles, which is 540, and they do. So that means we probably did it correctly. So for the next problem, how many sides do we have? We're going to have to do the work over here. There are 6 sides. Okay. So the degrees, let's just say total. And I'm going to just use the degree symbol right here. So total degrees are going to equal, n would be the number of sides, which is 6, minus 2 times 180. That is a hexagon. How many degrees are inside of any hexagon? Yep. $720. There you go. So the number of degrees in any hexagon is 720 degrees, including this one. So we have to write an equation adding up all 6 sides, combining like terms, to set equal to 720. Now, to make our lives a little bit easier, I would not suggest writing x plus 2 plus x minus 4 plus x plus 6 plus x minus 3 plus x plus 7 plus x minus 8. That would be a little overkill. It would be a lot of writing as well. What I usually do with stuff like this is I'll just look at, okay, how many terms here have x? Well, 6 of them do. Each of them has what number in front of it if we were to write a number in front of it? 1. So how many x's do we have? 6. So that'd be 6x. All right. So 6x. And then if we just go around the circle, putting together the numbers, we'll be able to get what we need. So let's see. 2, positive 2 and negative 4 is negative 2. Negative 2 plus 6 is positive 4. 4 minus 3 is 1. 1 plus 7 is 8. 8 minus 8 is 0. So that means it's just 6x equals 720. That's kind of nice. Anybody else get 0? Yeah, okay. I just want to make sure I did my math. All right. So yeah, soon as Zach gets back. Yeah. So to solve for x, we just divide by 6. So that should be a pretty quick thing to do. What does x equal? 120. Great. So x is equal to 120. All we need to figure out here is the measure of angle E. So here's E. Here's E. If x is 120, add 6 to it. What do you get? 126. There you go. Answer's D. Does this seem a little more straightforward than centers of triangles? Hopefully a little bit. Okay. All right. Any questions on that before we continue? I think we'll be able to move pretty quickly through today's. So let's talk about this next one. I don't know how much time we'll necessarily spend on this next question, but we'll see what we can do with it. Interior angle measures of a regular polygon. Okay. So it says Penny is building a house using a floor plan that she designed. What is the measure of angle ABC? So the measure of angle ABC, that would be, I'm just going to highlight the angle we need. Just as I've been talking with Miss Curtis and things like that, just in case you're still a little bit confused about how to find an angle based on its name with 3 letters, the middle letter is always where the angle actually lives. Like it's where it exists. It's the vertex of the angle. The point of the angle is at the middle letter. So if we start at A, go to B, and go to C, that would be this angle right there. We need to know how many degrees that angle is. And actually, this is not going to take very long. We'll definitely do this problem. So describe the task in your own words. List any questions that you may have. How can you find the answers to your questions? So first of all, what do we need to do? So like, what's the task asking us to do? Yeah. So find the angle measure. Okay. So find an angle measure of a, what shape is that? Hexagon, yeah. By the way, if you look on page 407 to the right of page 407, there's a list of shape names with the number of sides. So in case you don't know them all, if you go to the right over there on 407 in the margins, 6 sides, hexagon. So we're trying to find the angle measure of a hexagon. All right. What do we know? How will you approach the task? What do we know? What have you learned that you can use to complete the task? Trying to figure out the angle of a hexagon. We just did that in the last problem. How did we do it? Yeah. Okay. So, okay. So I'll find the sum of the angles. Okay, that's definitely something that needs to happen. What is something a little bit more particular in the details that we know about this particular hexagon, and what details are missing that we've had on the first couple of problems? Let's start with that second part. What detail are we missing from this problem that we were given on the previous problems? We just left a couple minutes there. Yeah. What's that? So yeah, we're given that all the sides are the same. So all sides are congruent. That is actually going to be really useful because of what we're not given. What are we not given in this problem that we were given in the previous two? Yeah, we were given like expressions for each of the angles, right? So yeah, we are not given expressions for any angles. No expressions for any angles, which makes all sides being congruent really important. Because if you think about it, does anybody know, have we talked about what a regular polygon is yet? I think we have, haven't we? Briefly, maybe. So a regular polygon means that all the sides are the same, like an equilateral triangle. What else do you know about an equilateral triangle if all the sides are the same? All the angles are the same. That's true of any regular polygon. So any polygon where all the sides are the same, all the angles also must be the same. So all the sides are the same, which means all angles are also congruent. That is a huge deal with this problem, because if we didn't know that, then we wouldn't be able to solve this problem at all, because there are no expressions for any of the angles. So now that we know that, go to part 3. What is your solution? Use your strategy to solve the problem. So write the equation that you will use. So let's just go back to the original diagram for a second. If we know they're all the same, and I was to call the angle that we need X, what would angle A be? If B is X, what is A? X, what's F? X, E, D, C, okay. How many X's? 6. All right, so for number 3, what's our equation to solve for this? Equals 720. That's weird. That's the same equation that we just solved for on the previous problem. So we actually know the answer to this already, because we already did this problem. So if you divide by 6, X is equal to what? Okay. So the sum of the interior angles of a regular hexagon is 720 degrees. Regular means all sides, all angles are the same. The measure of angle ABC is how many degrees? 120. All right. So let's see, write an argument that can be used to defend your solution. We'll go ahead and skip that. Because if you needed to explain it, you probably could. I'd rather move on and do some more math. So let's try the next one. This one right here. Miguel has commissioned a pentagonal. How many sides? 5. Pentagonal means the shape of a pentagon, 5 sides. Again, right over here, you got a list of sides and the name of the polygon. So if you ever get lost on that, go back to this page right here if you need to know how many sides it has based on the word. All right. Building a koi pond. A koi is a fish. To be built in his backyard. He wants the pond to have a deck of equal width around it. That he wants all the sides the same. The lengths of the interior deck sides are the same length. And the lengths of the exterior sides are the same as well. The measure of the angle of the pond formed by 2 sides of the deck is what? Basically, 2 sides of the deck would be like here and here. I don't know how well you can see that, probably not very well. What would be a good color to show up there? It's all kind of dark. I'll just make a thicker black line. How about that? Just like that. So 2 sides forming an angle. How many degrees will it be? I want you to work that out. You divide by 5, and the sum of the angles will not be the same as 720. It won't be the same because the more sides you add, the more degrees you get. That's what the polygon angle sum theorem is, which is, so you got to use this pentagon. So number of sides minus 2 times 180 tells you the total amount of degrees. Page 405. So once somebody thinks they have it, let me know. Everybody got it? It would be 540 for the total amount of degrees. How many angles are there? There's 5. They're all the same. So 108. There you go. 108 degrees. Each angle formed by 2 sides of the deck is 108 degrees. 540 divided by 5. Nice. A little bit easier. Yeah. All right. So let's keep going. Identify the polygon given the interior angle measure. Ooh, all right. So this isn't going to be too much more challenging either. So here we go. The measure of one interior angle of a regular polygon is 144 degrees. That is a bigger angle than what we saw in a hexagon, which probably means it has more than 6 sides. Stands to reason, right? Because if it was 108 degrees for a pentagon, 120 for a hexagon, this is 144. We're probably going to get more than 6 sides. So find the number of sides in the polygon. Let n equal the number of sides. We're just going to use the polygon angle sum theorem. Because all the angles of a regular polygon are congruent, because it says regular polygon, it means they're all the same. The sum of the interior measures is 144n. 144 degrees, n is the number of sides. So 144 degrees times the number of sides gives us the total amount of degrees. That's why we're using that. The polygon angle sum theorem of the interior angle measures can also be expressed as n minus 2 times 180. So what we can do here is we can write an equation that the total amount of degrees is equal to 144 times the number of sides. So we're going to write 144 right there. Are there any questions as to why we wrote this? Both of those things represent the total amount of degrees in the polygon. This one is each degree multiplied by how many sides there are, which we don't know. This one is the number of sides minus 2 times 180 equals the total amount of degrees in the polygon. Again, number of sides, we don't know what it is. But we are using only one variable, and if you have only one variable in an equation, you can solve for that variable. So let's do some work off to the side here. Let's head over here. If you were solving this particular problem, what would you do first? What would be your first step in solving this? What's that? Get rid of the parentheses by doing what? Yeah, distribute. Distribute the 180 to the n and the minus 2. So let's write the resulting step over here. So we're going to have 144n equals 180n minus what? Minus 360. Okay. We've got a variable on both sides of the equation. Let's go ahead and move the variable to the same side of the equation, meaning we have to do what? Subtract what? Yeah, subtract the 180n from both sides. Those will cancel. What is 144 minus 180? Negative 36. Okay. So minus or negative 36n equals, that's still a negative 360. If we are talking about number of sides in a polygon, what is the only type of number we can get for n? Type of number. Number of sides in a polygon. What's the only type of number that makes sense here? Not in terms of the number, but in terms of type of number. Which, by the way, is the answer, but what's that? Like in terms of type of number, yeah, whole number for sure. And it needs to be, we don't necessarily need an exponent, but it has to be, yeah, we need one variable here, which we have, and it needs to be positive. Yeah. It's got to be a whole number, it's got to be positive, right? And it has to be at least 3, because you can't have a polygon if you don't have at least 3 sides. If there's only 2, you just have an angle, it's not actually closed. So the only types of numbers that work for a polygon would be positive whole numbers that are 3 or more. So if we get a decimal, if we get a negative number, if we get a number less than 3, something went a little wonky and we need to fix it. But fortunately here, if we divide by negative 36, not 360, divide by negative 36, what do we get? 10. All right. So n equals 10, which means that the number of sides is 10, which means, it actually told us the answer, it is a regular decagon. And if you look over here to the right, 10 sides is a decagon. Which means that the total number of degrees inside of a decagon would be 1,440. Because if each angle is 144, if you multiply by 10, just add a 0 on the end. Okay. Try this one on your own or with a neighbor, but mostly without my help. Give it a try. And we've only got one more page after this. So yeah, this lesson's going nice and quick. Happy about that. By the way, if you want to speed up the process a little bit, just as a hint, the right side of your equation will always turn into this when you distribute the 180. So if you want to start your equation with 180 n minus 360 on the right, that'll take a step out of it because it'll always do that. Yeah, because the right side is always going to be this to start with, which means we'll always distribute that to start with, which means it'll always turn into that. There's one more page of notes.
Does that equal, wait, what does that equal again? 10?
On the last one, yeah, and it's 10. How many sides does this one have? What was that? 12, yeah. This one's 12. Number of sides for that last one is 12, because if we write the equation, 150n equals 180n minus 360, because this will always turn into that, so we may as well just start with that. It gets rid of a step. And I'm all about making things quicker. Subtract 180 from both sides, that's negative 30n equals negative 360. If you divide by negative 30, n equals 12. So we've got 12 sides. What's it called? Subtracting 180 from both sides. What do you think it's called? It's a dodecagon. Yeah, dodecagon. So 12 sides. We're going to say regular dodecagon. And right here, 12 dodecagon. The reason why it's n and then n-gon is because we don't really apply special names once we get to 13. So you could just say, like, if it's a 13-sided polygon, that's exactly what you would say, 13 sides. Yeah, or a 13-gon or a 13-sided polygon. There's no special names once you get past 12. So at least none that we're using. And I actually don't know any after 12 anyway. I'm sure there are words for them, but we don't need it. All right. Regular dodecagon for this last one here on this page. Any questions here before we move on? How are we doing today? Pretty good? Like in terms of learning, like this one's good. All right. Let's try another one. This one is going to be based off of exterior angles. So exterior angles of polygons. Theorem 7.2, polygon exterior angle sum theorem. Okay. This one says that the sum of the exterior angle measures of a convex polygon, which is, we're only dealing with convex, one at each vertex. So basically you are extending each side only in one direction, meaning, don't write this down, but for example, where 1 is, we are not extending it this way as well. That is not happening. It's only being extended in one direction to make a single exterior angle at each vertex instead of more than one exterior angle in each vertex. So the sum of all of the exterior angles, regardless, this is kind of weird, regardless of how many sides there are, the sum of the exterior angles will be 360 degrees. Triangle, quadrilateral, pentagon, hexagon, heptagon, octagon, nonagon, decagon, dodecagon. What's 11? Hendecagon. Interesting. 11. Hendecagon, yeah. The exterior angles will always add up to 360, whereas the interior angles add up to different amounts. The exterior angles will always add up to 360. So let's take a look at example 4.
Wait, sorry,
Exterior.
Okay.
So every angle here, 1, 2, 3, 4, 5, and 6, they are all outside of that shape. None of them are on the interior of that. What is that? A hexagon? None of these are on the interior of the hexagon. All 6 of these are outside. And so all those 6 angles add up to 360. The ones on the inside add up to 720, but the ones on the outside add up to 360. Always. Correct. What's that? Even on a triangle. Because if you have a regular triangle, if you have an equilateral, each interior angle is 60, which means the adjacent exterior angle would be 120. So if you have 3 exterior angles of 120, add those together, you get 360. On a while. All right. So example 4, here we go. Find the missing values. This is basically what we did before, except we don't have to figure out what they add up to this time. We know they just add up to 360. So these actually, in some ways, are a little bit easier. So the value of x, here we go. Add up all 4 of the exterior angles. So 6x is here. We've got 2x here. So that means we need the 9x and we need the 139. Those are the 2 that are missing from this equation. What do they add up to? 360. Yeah. All right. Let's just do some math over to the side. Come over here for a second. Add the x's together. So what's that going to be? 17x. All right. Plus 139 equals 360. Subtract 139 from both sides. Make sure you go and see that. Subtract 139 from both sides. $221. All right. 17x equals 221. Divide by 17. $13. It does. 17x plus 139 equals 360. And then subtract 139, so it's 17x equals 221. Divide by 17, x equals 13. So fill that in over to the right, x equals 13. All right, try the check one. Do the one right underneath it. Solve for x. All right, what number goes after 4x? 152. All right. Excellent. So you got x here, that's 2x. 2x more than that would be 4x. 52 plus 88 plus 12 is 152. Subtract 152. You get 4x equals what? 208. What's 208 divided by 4? 52. So, answer B, 52. All right, one last question. We're making good time today. So, any questions there before we work on the very last one? Yeah. All right, one more. Here we go. Oh, wait. So let me set this up real quick. Find the exterior angle measures. Find the exterior angle measures of the polygon. Exterior angle measures. A regular dodecagon has 12 congruent sides and 12 congruent interior angles. The exterior angles are also congruent because it's regular. Because angles supplementary to congruent angles are congruent. So exterior angles and interior angles are on a straight line, meaning that they're supplementary because they create a linear pair. I'll just go ahead and show you. Right up here. This exterior angle 1 with the angle right next to it on the inside Those are a linear pair, means they're supplementary, they add up to 180, which means in a regular polygon, all the exterior angles are also congruent. So if you have a dodecagon, you have 12 sides. So 12, let's see. Let n equal the measure of each exterior angle. I wish it wasn't n. I wish it was a different thing than n, because we were using n for number of sides earlier. Let's change that. I want you to change that. Change that to a. We were using n as number of sides earlier. I don't want to use n as angle measurement now, because that will maybe confuse things for some folks, and that's not what we want to do here. Let a equal the measure of each exterior angle, write and solve an equation. So how many exterior angles are there? There's 12. So 12 times the measure of each exterior angle equals what? 360, yeah, because exterior angles always add up to 360. So if you know how many sides you have and you have a regular polygon and you want to find the measure of each exterior angle, just take 360 and divide by the number of sides, which is 30. So the measure of each exterior angle of a regular dodecagon is 30 degrees. Let's go back a page. How many degrees was each interior angle? Bottom of the previous page. This is the information we started with at the bottom of the last page. How many degrees is each angle on the inside of a dodecagon? Regular dodecagon. 150. The exterior angle was 30. Those are adjacent on a straight line. What's 150 plus 30? 180. That makes sense. Okay. Try the last one. The measure of each exterior angle of a regular octagon is what? This one should take about 5 seconds. This last one down here. Very last one. Yeah, the check problem. Because we know the degrees of all of the exterior angles, and if it's a regular polygon, all of the angles are the same measure. So what's the answer? Ooh, is it though? How many angles are on an octagon?
Oh, octagon?
Yeah.
Oh,
Okay.
oh.
Oh shoot. 45 is the answer. Yeah, there's 8 sides on an octagon. So we're gonna get 360 divided by 8 and 45. So each angle on the exterior of a regular octagon is 45 degrees. Cool. That's it. That's your entire first lesson of this new unit. Hopefully you're feeling a little bit better about this unit so far than the last one. So we're looking at about 13 minutes. I'm going to go ahead and tell you what your assignment is real quick.